This video is for page 11 of your interactive notebook on physical and chemical changes. We're going to start by defining physical and chemical change. A physical change is a change in which the identity of the substance does not change, whereas a chemical change is a change in which new products are formed by changing the identities of the reactants. So the key difference is that in a physical change, the identity of the substance being changed will not change, but in a chemical change, that identity will be changed. So on the left hand of the notebook, we're going to illustrate a physical change first, and you are free to come up with your own example of a physical change. I'm using the example of an ice cube melting. So this substance right here is water. It's frozen water in the solid phase, and then when you heat it to the melting point, it melts into the liquid phase, and this is an example of a physical change. Now for chemical changes, we're actually going to look at a lot of different examples. And so we're going to list 5 different indicators of chemical change. These are things that you should be able to observe in the lab that would let you know whether or not a change is physical or chemical. And then for each of these 5 indicators of chemical change, I'm going to have an example picture. So for the first one, the first indicator of a chemical change is a change in color. So on the left hand of our notebook, the example that I will use is that of a nail rusting. So we go from a light gray metallic nail to an orangish brown rusted nail. This is a chemical change. It's the oxidation of this nail, and we know that a chemical change is occurring because there's a distinct change in color, indicating that a new product has been formed. The second example, or the second indicator, is a change in odor. So if we ever observe a change in odor, that might be an indicator that a new product is being formed. And on the left, the example that I'm going to use is going to be a hamburger that sits out for a little too long and starts to get rotted. And that change in odor is an indicator that a chemical change has occurred. In fact, it's going to be a lot of different chemical changes that are occurring as that food breaks down. The third indicator of chemical change is a change in energy. And this can be either heat or light. So if we notice that a reaction is either getting colder or hotter, it's either absorbing or releasing energy, or if it's absorbing or releasing light, that's a good indicator that it's a chemical change that's occurring. Previously, we talked about endothermic and exothermic reactions, and that would relate to this. That change in energy can be either positive or negative. So if it's an absorption of energy, it's endothermic, and if it's a release of energy, it is exothermic. So on the left, I'm going to show an illustration of a change that releases both light and heat, and that would be burning a log. So I'm going to take this log and light it on fire, and that fire is both a release of light energy and heat energy. The fourth indicator that the change is a chemical change would be the formation of a gas. And whenever we see this in the lab, it's going to look like bubbling usually. I mean, most gases are going to be colorless and we won't be able to see them, although they might have an odor. But you'll normally see that a gas is forming whenever it's forming in a solution or in a liquid and it bubbles out. The example that I'm going to have on the left is adding acid to a piece of metal. We'll learn later in the year when we talk about acids and bases that most acids react with most metals to form hydrogen gas. So whenever I pour the acid on the piece of metal, we're going to get some fizzing and bubbling, and that's an indicator to me that the change that's occurring is a chemical change. Now the last indicator of a chemical change is something new that we haven't talked about yet, and that's the formation of a precipitate. And a precipitate is an insoluble solid that forms when two solutions react. So on the left, we're going to illustrate a very common precipitation reaction, which is the precipitation of lead to iodide. So I have these two solutions that I'm going to mix together. And whenever I do that, they're going to react with one another. And to the very bottom of this test tube is going to settle an insoluble yellow solid. And that yellow solid is lead to iodide. And the solid doesn't have to be yellow, right? I mean, we can precipitate a lot of different things. So we could precipitate white powders. We could precipitate even metals in certain types of reactions that we'll talk about later in the year. But if we get a solid that settles to the bottom and it's insoluble and it's not part of the solution, then that is an indicator of a chemical change. So this is all 5 of them right here, all of the 5 different indicators, and it's worth noting at this point that these indicators are not perfect. So for example, I'm sure that you can think of situations in which we would see the formation of a gas that are not a chemical change. The obvious one would be boiling. Whenever water boils, we do see formation of a gas, and that's because the liquid phase is transitioning to the gaseous phase, but it's not a new gas. The identity of the substance isn't changing. So you have to be careful whenever you're applying these and make sure that the change that you are observing is a chemical change, and usually it's best if you can spot more than one of these changes taking place. So for example, in this one we have both a color change and the formation of a precipitate. In this example right here we have release of light, release of heat, we're going to have a color change, we'll have formation of a gas. So the more changes that are, the more indicators of chemical change that you can observe, the easier it's going to be to make sure that that really is a chemical change. The last thing that you're going to do for this page in your notebook is glue in the worksheet, Application, Physical and Chemical Changes, and then you'll be finished with page 11 of your interactive notebook on physical and chemical change.